Question number 51, you're given a lot of information, so my recommendation is you just write it down and label it as it's given to you. So it says you have a 2.50 decimeter container, so that's a volume. And it's at a pressure of 85 kilopascals. It's heated from 25 to 75 degrees. So your temperature 1 is 25 degrees, but remember that needs to go to Kelvin, so I just change it right away before you have time to forget. And then you have a second temperature of 75 degrees, which also needs to be changed to Kelvin. So that's going to be, I believe, 348, if I got my math right. And it says the container expanded, so now I have a new volume to 2.75 decimeters cubed. And they want to know the new pressure. So I'm just using the combined gas law here. V1 times P1 over T1 should be equal to V2 times P2 over T2. So I'll go ahead and set it up. So there's how I've set mine up. So you're just going to have to go ahead and cross multiply and divide to solve for this. I don't know why this doesn't all scroll together. So let me just move it over here. I'll do this in red. So I've got 2.5 times the 85 times the 348 is going to be equal to the 298 times the 2.75 times P2. So I'm going to have to divide both sides by the 298 and the 2.75. So that means I'm dividing up there to 298, 2.75. And so I'm going to come up with P2 being equal to 90.2, or I guess I'm restricted to really 2 sig figs, so 90, and the label would be the same as pressure 1, kilopascals. So on 52, I've written down all the numbers they've given me and labeled each one, and I'm being asked to find the initial temperature, or T1. So again, if I set up P1 times V1, or V1 times P1, whichever way you want it, and divide by T1, it should be equal to P2 times T2, or times V2, I'm sorry, over T2, which is 300 Kelvin. So when I cross multiply and divide, I end up with T1 times 2 times 10 to the 5th times 350 equal to 1 times 10 to the 5th times 675 times the 300. And when I solve for T1, divide both sides by those two values to get T1 alone, I end up with T1 being equal to, so I've got T1 being equal to 289 Kelvin, or 16 degrees Celsius. And I don't think they asked you to they just said determine the initial temperature. So as long as you label it properly, you could leave it 289 Kelvin or convert it back to Celsius. Number 53, this type of question is common, especially on paper 1, the multiple choice, where they're having you just look at relative changes. So the absolute temperature of 4 decimeters cubed of hydrogen gas is increased by a factor of 3. So I've written down my initial volume as 4 decimeters cubed. I've written down my temperature as T1, and then I've shown that temperature 2 is going to, I've written it down T1 as just being X, and T2 then will be 3X. It's increased by a factor of 3. Pressure 1 I've written down as Y, and then it's going to be increased by a factor of 4, or P2 is going to be 4Y. And they want to know what effect will the volume have, or what will be the final volume. So when I set this up as V1 times P1 times Y over T1, which I'm going to leave as X, and then I'm going to have V2, which I'm trying to find, times P2, which is going to be 4Y, over T2, which is going to be 3X. So now when I cross multiply and divide, it looks like a real mess, but it really actually is fairly simple. I've got 4Y 3x equal to x, z, and 4y. So now what I get, remember, it's z that I want all alone. So if I divide by x and 4y on each side, my y's cancel out, my x's cancel out, my 4 even cancels out. Over here, I am left with 3 being my value for z. And then it would also be decimeters cubed, since that was my original volume. So here's the information I've given from 54, and I'm being asked to find the volume. So now I need the ideal gas law, and I can either use it as written, PV equals nRT, and I can simply change the 4.4 grams of CO2 to moles to plug in for N before I get started. Or I can go ahead and use PV equals little m RT over big M, and I can just plug in the 4.4, and I'm still going to have to calculate the molar mass to put it in there. So it really doesn't matter, whichever way you prefer. So I'll go ahead and use the second equation. So I've got 90 kilopascals. V is what I'm trying to find. I've got 4.40 grams. The R value, remember, because it's kilopascals, so the value is 8.314. Remember, last year we were used to seeing that as 0.008314. That would be if it was in pascals, but kilopascals we multiply by 1,000, so 8.314. And then my T is 300 Kelvin. And then I need my molar mass for CO2, 44.01. So when I go ahead and solve for this, I'm going to end up dividing both sides by the 90 kilopascals to get X alone. And I come up with X having a value of 2.77, and then that would be in decimeters cubed. So number 55, they tell you that a noble gas, so it's over in family 8A, has a density of 5.84 grams per decimeter cubed at STP, and they want you to calculate its molar mass. Now, you could use the ideal gas law and plug in for this, but since it's at STP, remember at STP, we already know that 1 decimeter, or 1 mole is going to be 22.7 decimeters cubed, and what I need is moles and grams. So I could take my 5.84 grams per decimeter cubed, and I want moles on the bottom, and I don't need the decimeters cubed. So if I set this up with 22.7 decimeters cubed per 1 mole, I would end up with my molar mass of grams per mole. And when I do that, I come up with 132.57 grams per mole. And if I look, the closest thing that is xenon. So 56 is kind of a hot mess when you start. You've got all kinds of units here, and ultimately we're trying to find molar mass using the ideal gas law, or as I've got it written down on the bottom here. So the 12.1 milligrams, I went ahead and changed to grams. The volume I changed to decimeters cubed. And then the temperature, I've got it 298 Kelvin and then 1,300 pascals. And my R value, I'm going to change this here because the R value depends on your volume and your pressure unit when we look at them metrically. So 8.314 can represent either liters per kilopascals, and I've got liters but pascals, or it can represent meters cubed and pascals. So what I really need to do is I need to change one of my measurements up here, either my pascals to kilopascals or change my volume so that it matches. So I've already got it in liters, so I'm going to go ahead and change this to kilopascals because that's a pretty easy change. Just like it sounds, a kilopascal is a bigger unit, so there's 1,000 pascals in a kilopascal, so this would be 1.300 kilopascals. And now I can go ahead and use this R value with my decimeters cubed or my liters. So now when I plug in, I'm going to go ahead and pause and write all my numbers in so you don't have to sit and watch me. So I've plugged my numbers in, and then I've rearranged the equation, and when I plug this all in, I'm coming up with a molar mass of 90.43 grams per mole.